Hello everyone. The last chapter, I'll talk about the introduction of Huawei Big Data Solution, FusionInsight HD, including its architecture and functions of each component, and also some features. After this course, we'll be able to understand Huawei Big Data Solution, FusionInsight HD. And also, I'll introduce some features and success cases of FusionInsight HD. First, let's take a look at FusionInsight overview. Well, traditionally, an enterprise will have some computers to store and process big data. Data is usually stored in RDB, relational database, such as Oracle, MySQL, SQL Server. We can interact with this database to process data and present it to the users for analysis purpose. But when it comes to dealing with huge amounts of data, it's really hard to process such data through a traditional database server. That's why we need a solution to deal with this problem. So Apache Hadoop was born. It's an open source framework that fundamentally changes the way enterprises store, process, and analyze data. It's a collection of open source software utilities that facilitate using a clustered environment to solve problems involving massive amounts of data and computation. So what is a cluster? A cluster means a group. When we have multiple independent servers, we can group them to work together to ensure high availability, scalability, and reliability so that we can form a server cluster. Applications based on the server cluster ensure that users have uninterrupted access to important resources running on the server, thus improving working efficiency. Why is uninterrupted? Let's say if one machine in this cluster fails, the workload will be distributed across the other servers, and this enables uninterrupted services to the client. Here is a Huawei strategy map. From this figure, we can see that the big data platform is the foundation of the entire IT system and is of great importance. But Apache Hadoop is open source. Of course, it's unstable and have some bugs, so Huawei adopts the essence of the open source Hadoop, eliminates bugs, and improves some functions. It also uses tens of thousands of test cases to ensure the scalability of the enterprise version. FusionInsight is a distributed data processing system that provides a unified enterprise-level big data storage, query, and analysis platform by enhancing functions of the open-source Hadoop software. So it's much more stable than the open source. It supports swift integration and management of large datasets of various types, advanced analysis of native information and visualization of available data for spatial analysis. With Huawei FusionInsight, enterprises can capture new business opportunities and discover risks by analyzing and mining various massive data in a real-time or non-real-time manner. Let's take a look at the architecture of FusionInsight platform. It consists of FusionInsight HD, FusionInsight MPPDB, FusionInsight Porter, FusionInsight Miner, FusionInsight Farmer, and FusionInsight Manager. So FusionInsight Libra, which is FusionInsight MPPDB, is a relational database for large-scale parallel processing. It adopts the massive parallel processing architecture, supports both row-based and column-based storage, and it's capable of processing PB-level data. Fusion Insight Manager is a big data operation and maintenance platform. It implements highly reliable and secure cluster management for Fusion Insight HD components. It supports installation and deployment, monitoring, alarm management, user management, rights management, audit, service management, health check, fault locating, upgrades, and patching of large-scale clusters. Fusion Insight Porter is used for data ETL, which is extracting, transforming, and loading data. Fusion Insight Miner is a data analysis platform that mines valuable information from massive data. It's based on distributed storage and the parallel computing technology of Fusion Insight HD. Fusion Insight Farmer is a big data application container that provides a unified development, running, and management platform for enterprise applications. And Fusion Insight HD is a big data processing platform. It's a distributed data processing system and provides large capacity data storage, query analysis, and real-time stream data processing and analysis capabilities. It includes the following components: HDFS, HBase, Yarn, Zookeeper, Hive, MapReduce, Spark, Storm, and Flink. In 2015, Huawei ranked number 2 in the Hadoop open source community, second only to Hortonworks. And in 2016, Huawei ranked number 1 in the Hadoop open source community. Next, let's see the features of Fusion Insight HD, which are some functions that Apache Hadoop doesn't have. You don't need to understand every detail of it, just need to have a rough understanding of them. The first one is high reliability. Fusion Insight optimizes and improves reliability and performance of main service components based on Apache Hadoop open source software. There are two parts: system reliability and data reliability. For system reliability, all components without SPOF, which is single point of failure, and HA, high availability for all management nodes. Data and compute nodes of the Hadoop open source version are designed based on the distributed system. Therefore, the whole system is not affected by single point of failures of data and compute nodes. However, management nodes operate in centralized mode. SPOFs of management nodes will affect the whole system. Huawei Fusion Insight provides the dual-node mechanism for management nodes, such as HDFS name node, Hive server, HBase HMaster, Yarn resource manager. The management nodes work in active, standby, or load-sharing mode, preventing impact of SPOFs on system reliability. If the active node fails, the standby node will immediately take over the job. Besides, Fusion Insight supports software and hardware health status monitoring. It invokes of the IPMI of the x86 server to monitor physical server features, such as the temperature, voltage, fan module status, and power status. Huawei Fusion Insight HD divides the entire network into two planes, the service plane and management plane. These two planes are physically isolated to ensure security of the service and management networks. As for data reliability, first, Fusion Insight HD provides the remote RD function by configuring the active standby cluster relationship and data tables to be synchronized. When data of the active cluster is damaged due to disasters, such as flood or earthquake, the standby cluster immediately takes over services. Also, to improve the data reliability, data will be packed up to a third-party server manually. Besides, FusionInsight supports key data power-off protection. After power supply is restored, services are running properly regardless of a power failure of a single node or the whole cluster, which ensures data reliability in case of unexpected power failures. Key data will not be lost unless the hard disk is damaged. Huawei FusionInsight HD is a platform for massive data management and analysis, and it features high security. It ensures user data and service running security from the following aspects. System security. Users can deploy third-party antivirus software based on their service requirements. For the operating system and interfaces, Huawei FusionInsight HD provides some security measures like hardening OS kernel security, installing the latest OS patch, and so on. Permission authentication. FusionInsight HD manages rights based on the role, ensuring user rights authorization, and can control access rights to different components for different users. Data security. Data verification ensures data integrity during storage and transmission, and the data security is ensured by encrypted data storage and access control. Here explains the network isolation in more detail. We know that Hadoop is a distributed computing system requiring all service nodes to be interconnected. Considering risks in reliability and security, FusionInsight supports network classification, which is to divide the network into three levels, namely cluster service plan, cluster management plan, and maintenance network beyond the cluster. Physical isolation is implemented for these three levels. Network isolation prevents obstruction of cluster management channels due to heavy load on service platform and also prevents external attacker from accessing service data through the channel. FusionInsight also provides visualized cluster management using FusionInsight Manager. Everything is under your control. We don't need complex command line operations anymore. We can easily configure service components, make one-click cluster deployment and expansion, which is easy and quick. It provides overall system monitoring and alarm management. We can view the service status and know the status at a glance. FusionInsight tool is a health check tool provided for technical support engineers and maintenance engineers. It can check the health status of nodes and services in the cluster, detect potential problems in the cluster in advance, and generate a health check report. This enables technical support engineers and maintenance engineers to know the system health status quickly. It composed of two parts, FusionCare and SysChecker. FusionCare provides visualized inspection UI, environment management, task management, and report management functions. And SysChecker provides a feature of FusionInsight inspection. And FusionInsight simplifies the code. Here makes a comparison between native APIs of Edge-based and enhanced APIs. We can see that there is about a 50% reduction of code, which is easy to develop. Spark SQL is the module used in Spark for structured data processing. Its capabilities are enhanced in terms of standard SQL syntax compatibility. So in Spark applications, you can seamlessly use SQL statements to query structured data. And when using Carbon data file format, Spark SQL supports data insert, update, and delete. Besides, FusionInsight makes a long-term scalability test of Spark, such as memory optimization, communication optimization, and scheduling optimization. So it's highly stable and with high performance. The JDBC server of open source Spark supports only single tenant. A tenant is bound to a young resource queue. But in FusionInsight Spark, JDBC server supports the multi-tenant feature. Different tenants submit tasks to different young queues, and the containers of young are used to isolate resources. In Spark SQL tables, massive small files will be generated. Block here is the smallest file storage unit in HDFS. Each small file corresponds to a partition in the Spark, that is, a task. In this case, Spark will have lots of tasks to process. If shuffle is involved in the SQL logic, the number of hash buckets will be increased dramatically, severely hindering performance. So in order to improve performance, FusionInsight adopts an algorithm to merge small files in the table. Here mentions about a new file format called Carbon data. Why do we need this kind of file format? For a data warehouse, we have three different access types of data: OLAP, sequential access, and random access. OLAP means online analytical processing. These three types are applied for different scenarios, but we want a file format that meets the requirement of all these three access types. That's why Carbon data was created. Carbon data is a new Apache Hadoop native file format for faster interactive query using advanced column-based storage, index, compression, and encoding techniques to improve computing efficiency. In turn, it will help speed up queries over PB-level data. The goal of Carbon data is to provide ultra-fast response to ad hoc queries on big data. Carbon data has the following features, like it's fully compliant with Spark SQL and supports all SQL queries which can run directly on Spark SQL. It supports insert, update, and delete operations. Carbon data has two key advantages: quick query response and efficient data compression. High-performance query execution is one of the key technology advantages of Carbon data. Carbon data queries run approximately 10 times faster than Spark SQL queries. Carbon data uses a specialized file format designed from the ground keeping query performance in mind. It combines multiple indexing techniques along with the dictionary encoding and several pushdown optimizations to deliver the best possible response time for queries on TB-level data. Carbon data uses a combination of few lightweight compression and heavyweight compression algorithms to compress the data. Carbon data can reduce the space required for storing the data by 60% to 80%, giving huge saving on the storage hardware cost. Flink is a unified computing framework that supports both batch processing and stream processing. The core of Flink is a stream data processing engine that supports data distribution and parallel computing. Most of the time, we use Flink for stream processing because it's a top open source stream processing engine in the industry. So while we integrated Flink into FusionInsight HD. HBase is a distributed, column-oriented storage system built on the HDFS. The column-based HBase features high reliability, performance, and scalability. HBase is suitable for storing big table data and allows real-time data access. In FusionInsight HD, HBase supports visualized modeling, which can help database administrators with modeling design and to make HBase easier to use. Besides, it promotes the division of labor. For example, database administrator focuses on data table modeling and developers focus on names and columns to be used of user tables. In HBase, the number of columns may increase, resulting in a poor query performance. So in order to improve query performance, we need to merge some code fields, which means some columns with data that accessed infrequently for the application. For example, we have a table of user data like this, with columns ID, name, phone, and other code fields. Only the first three columns are accessed frequently, so we need to merge the code fields by ourselves to improve query performance. But this leads to increased development complexity, and we also need to maintain relative metadata information. So for this reason, FusionInsight HBase supports merging code fields, which is not very useful for applications. Security risks are quite important when we talk about big data. So in FusionInsight, Hive and HBase supports encryption of sensitive data. To be more specific, Hive supports encryption of tables and columns, and HBase supports encryption of tables, column families, and columns. As for the encryption algorithms, they support AES, SM4, and user-defined. So with this feature, the whole system is more secure with multiple algorithms and has less risk of sensitive data leakage. Okay, that's all for the first part of this chapter. Hello everyone, let's continue the content of this chapter. HBase is a distributed storage database of the key value type. Data of a table is sorted in the alphabetic order based on row keys. If you query data based on a specified row key or scan data in the scale of a specific row key, HBase can quickly locate the data that needs to be read, enhancing the efficiency. However, in most actual scenarios, you need to query the data of which the column value is a certain one. HBase provides the feature to query data with a specific column value. All data is scanned in the order of row key, and then the data is matched with the specific column value until the required one is found. The filter feature scans some unnecessary data to obtain the required data. Based on the preceding description, the filter feature cannot meet the requirements of the frequent query with high performance standards. To solve this problem, the HBase secondary index is generated. It enables HBase to query data based on specific column values. We make a comparison between noIndex and secondary index. Take a look at this table. When noIndex is used during query, the column A needs to be matched in the entire table by row to search the specific value of column A such as 3, which results in long time delay. When using secondary index table is searched first to identify the location of this row, which narrows down the search scope and reduces the time delay. FusionInsight HBase supports pre-association of tables to improve the join performance and simplify the development of HBase multi-table services. For example, We have a transaction table and count info table. They have a common column, which is account ID, so we can associate these two tables so that we don't need to scan two tables when we want to find out the amount and account name of a specific account ID. We only need to search one table. To be more specific, multiple user table data is stored next to each other physically by using the H-based internal mechanism. It can accelerate the query 5 to 100 times by pre-associating the data before loading data into databases instead of during the query. HFS, which is H-based file stream, is an independent H-based file storage module. It's used in FusionInsight HD upper layer applications by encapsulating H-base and HDFS interfaces to provide these upper layer applications with functions such as file storage, read and delete. In Hadoop ecosystem, the HDFS and HBase face tough problems in massive file storage in some scenarios, like if massive small files are stored in HDFS, NameNode will have great pressure, or some large files cannot be directly stored in HBase due to HBase interfaces and internal mechanism. So, the HFS is developed for the mixed storage of massive small files and some large files in the Hadoop. Simply speaking, massive small files and some large files need to be stored in HBase tables. Small files can directly store in MOB, and large files can directly store in HDFS. For such a scenario, the HFS provides unified operation interfaces similar to H-based function interfaces. Label-based storage is a feature of HDFS. For example, if data required for online applications and for offline applications are placed in the same node, it may cause input or output conflict and affect services. So if we can flexibly configure the node to store the HDFS data blocks based on the data features by configuring one label expression corresponding to the HDFS directory or file and each data node corresponding to one or more labels, then data nodes are specified for data block storage. In this case, IOs of different applications are isolated to ensure SLA, which is a service level agreement of applications. Besides, system performance can be improved with label-based storage. If the label-based data block placement policy is used for selecting the data node to store the specified files, the range of data nodes will be selected based on the label expression of the files, and appropriate nodes will be selected from the range of data nodes. In FusionInsight, users can store the replica of data blocks to the nodes with different labels accordingly. Also, resource utilization can be improved with labels. Different types of applications are running on nodes with their own specific labels, which absolutely isolates the computing resources for different applications. Besides, for those applications that require special nodes, like Spark application needs to run on nodes with large memory, we can label the nodes so that resources are scheduled on demand. FusionInsight HD also has a feature that it can adjust the CPU configuration periodically. Different services need different resources over different time periods. For example, there is more demand for real-time applications from 7 a.m. to 8 p.m. So, we can allocate 60% resources for them and 40% resources for the batch processing applications. Then after 8 p.m., the demand of batch processing applications is much more than the real-time one. We can adjust the resources allocation rate into 80% and 20%. In this case, the utilization of the system is highly improved. And this feature shows that we can use FusionInsight Manager to check the resource distribution anytime. We'll be able to know which nodes need more resources so that we can make adjustment. When a Hadoop cluster goes wrong, we may need to adjust the level of the log to locate the problems. But when adjusting the log level, we need to restart the cluster, which may influence the services. FusionInsight HD solved this problem. It supports adjusting the log level dynamically on the web UI by users without restarting the cluster. There are many key data in the Hadoop cluster, like cluster configuration, user information, and Hive or HDFS service metadata that need to be backed up to ensure data security and reliability. The backup of key data in Apache Hadoop can be completed only by developing scripts related to data backup and periodic scheduling. The operation is complex and complicated, whereas FusionInsight Manager supports backup management and recovery management of key data, which is easy to operate. Backup and restoration tasks are monitored in real time. FusionInsight Manager introduces the multi-tenant concept. CPU, memory, and disk resources in cluster can be integrated into a set, which is called a tenant. If there are multiple tenants, a multi-tenant system is called. A tenant includes computing resources, storage resources, and service resources. The multi-tenant function supports layered tenant mode and allows an administrator to dynamically add or delete a tenant to implement resources isolation and manage computing and storage resources of tenants. Here, the computing resources are the young task queue resources of a tenant. Users are allowed to modify the task queue quota and view usage status and statistics of task queues. And the storage resources refer to HDFS storage. Users are allowed to add or delete tenant HDFS storage directories and set the directory file quantity quota and storage space quota. As the unified tenant management platform of FusionInsight HD, Manager provides a portal for users to create and manage tenants in the cluster based on service requirements. Roles, computing resources, and storage resources are automatically created when tenants are created. By default, all rights on the new computing and storage resources are assigned to the tenant roles. After the computing or storage resources of tenants are modified, the rights of the related role are updated automatically. Manager allows administrators to centrally manage component permissions. After introducing the role concept, Manager centrally displays and manages component permissions in role-based access control mode, and organizes these permissions based on permission sets to form a unified system permission concept. By doing so, common users cannot obtain internal permission management details, and permissions become easy for administrators to manage greatly facilitating permission management and improving user experience. The Hadoop cluster is sensitive to time. For example, the edge-based data is recorded based on the operating system timestamp. If the time is not synchronized, new data will be overwritten by the original data. Therefore, users need to ensure that the internal time of the cluster is consistent. Users need to configure NTP, which is Network Time Protocol, a networking protocol for time synchronization between computer systems over packet-switched, variable latency data networks. FusionInsight Manager supports automatic configuration of NTP and NTP start or stop, and also alarm and recovery guide for time asynchronization. The Hadoop cluster depends on the host name. During the installation, the mapping between the IP address and host names of all nodes in the cluster must be added to the host files under the etc directory on each node. If you want to expand the capacity of a cluster with more than 1,000 nodes, it's hard for you to manually modify the file on the existing nodes. So FusionInsight Manager provides a function that during cluster installation, the information in the host file of all nodes is automatically updated. When a node capacity is expanded, the information of this file of all nodes is also automatically updated. In this case, users don't need to configure manually, reducing the probability of configuration error and environment preparation time. Rolling restart refers that after the software of a service or role instance is updated or the configuration is modified in a cluster, related objects are restarted without interrupting services. Rolling upgrade is an online upgrade mode. During the upgrade process, service interruption interval can be minimized. Rolling patch indicates that patches are installed on a component or multiple components in a cluster without interrupting the services or with a minimized service interruption interval. The following part is some successful cases of FusionInsight. First one is about transportation. The traffic problem comes down to the following four aspects: secure, well-organized, smooth, and intelligent. About security, for example, a city has 50,000 of truck accidents every year, accounting for 62.9% of the total traffic accidents in the city. And in the first-tier and second-tier cities, about 20 million new traffic data records are generated every day. So it may take technicians a lot of time to analyze this data manually, and the preparation of data, the algorithm, the development of applications may also cost a lot of time. Besides, the traffic detection capability is of low efficiency and low reliability. For 5 types of devices, such as road surveillance, traffic checkpoint, e-police, traffic detection, and traffic guidance, their information is closed. The mechanism is solidified, and the information collected from these devices is fragmented. Huawei use big data technologies to build deep learning platform. By deep learning and intelligent analysis, the platform lays a foundation for digital transformation of traffic. The Traffic Big Data Analysis platform provides the following four analyses, which is key vehicle traffic analysis, key vehicle violation analysis, detection replacement analysis, and buy and sell analysis. With this platform, the security and orderly management capability of cross-province traffic is highly improved. The second example is about precision marketing. The traditional marketing systems have some limitations like precise sales cannot be implemented, real-time marketing by event or location cannot be implemented, or unable to handle semi-structured data. So in order to implement precision marketing, Huawei FusionInsight HD provides multiple computing frameworks for different scenarios. For example, Foom is used for real-time collecting data. Spark is an iterative computing engine based on memory. MapReduce is an offline computing framework. Streaming is for real-time stream computing, and Flink combines batch processing and stream processing. With these computing frameworks, FusionInsight HD platform can help to implement real-time precision marketing. We can analyze consumer data, generating analysis report. Based on this, we can filter customer group, make correlation analysis, create different marketing activities for different customers through SMS or app or Twitter, thereby realizing precision marketing. The marketing solution based on big data analysis and mining has the following 5 features: precise, comprehensive, real-time, reliable, and easy to use. The next example is about carrier. The challenges include that there are many service systems, and there are 7 service big data platforms existing. Besides, the problem of data redundancy is serious. For example, in a database, values are repeated unnecessarily in one or more records or fields within a table, or the field is repeated in 2 or more tables. And platform convergence and evolution are difficult. What's more, data sharing among departments is time-consuming and it may take several months to get data from other departments. It's difficult to innovate data or to mine values of data. So, in order to solve all these problems, customer needs an enterprise-level big data platform featured by high reliability and security, as well as simplified management, achieves unified storage and management of data in MSS, OSS, and BSS domains. Powerful multi-tenant management addresses resources and data sharing challenges of the big data platform among departments, and unified data management and full data convergence lay the foundation for data service innovation and value monetization. All of this can be realized by FusionInsight. With FusionInsight, it can realize unified storage, management, distribution of data by deploying a unified big data platform. Resources and data can be shared through the big data platform by the multi-tenant management. The resource utilization is improved by 166%. The final example is about Philippine PLDT to convert and archive massive CDRs. The challenges include that the data volume is massive. The incremental data size is about 2 TB per day. The existing solution has weak scalability. Data can be stored for only 1 month, and the user experience is poor due to query with high latency, and ROI is low. How to solve these problems? It needs one-stop solution which meets both the requirement of structured and unstructured data storage and analysis, and it needs an enterprise-class header platform which provides high reliability, security, simplified management, and development. With this solution, customers can easily cope with data growth challenges in the next 5 years. The query performance is increased by 7 times, which highly improves the service experience, and the procurement cost is also reduced, and future maintenance costs are low. So this chapter mainly talks about Huawei FusionInsight HD, including its features, application scenarios, and also it describes Huawei FusionInsight HD success cases in the industry. Okay, that's all for Huawei Big Data Solution FusionInsight HD. Thank you.